Hello, everyone. I'm very happy to be here as a speaker to give you this session. It's about using Delta Lake to transform a legacy Spark circle to support complex CRUD operations. Before that, let me introduce myself. My name is Lantao Jing. I'm a software engineer at eBay Infrastructure Data Platform. I have over 8 years big data infrastructure development experience, and I'm focused on Spark internal optimization and efficiency platform building. You can contact me with below 3 links. Let me start the agenda. First, I will introduce the background and our requirements. Then I will show you how we do the cross-table update, deleting, and insertion, and our amazing optimization works. Finally, is management works. And the last three, I will mix together with the timeline. Here is the background. Maybe some of you here already know, in eBay, we are migration our data warehouse from commercial data warehouse to open source. So different data warehouse has different SQL syntax. So we need the syntax is compatible with the commercial product. For example, we are migration our ad hoc workload from the MPP engine to Spark Circle, but the Circle engine and the MPP engine, they are different syntax. We need this update delete syntax. So besides, the CRUD is a fundamental requirements in data processing. Before that, if we didn't have the update and delete, since we developed a file format, it's very like have ACID to support this. And also our customer always use the left join to update some incremental data to performance update. That's why we need the fully circle syntax CRUD. Besides, database is a trend in analytic data sets. For example, Google BigQuery, this is a big data analytics data sets, but the interface is very like a database. Besides, with a CRUD, we can provide opportunity with new approach in many scenarios. To achieve this, we have 4 requirements. The first one is we need to fully support the commercial data warehouse SQL syntax. So in this commercial data warehouse, they provided a very complex update delete SQL syntax. You can see in the right picture, they can join single table join, single table update, and they can join with another table to update the target table. So besides, we need to match it in performance. And this is very significant important. And our work is based on the Spark 2.3 last year. So we called it Legacy Spark. We have developed many works like many features and optimizations in this Spark version. So for this feature, we also need to, based on this Spark, and it's integrated with these features. Another is we need to deliver these features to customer in a short time because our customer is blocking in migration. Here, our project is started from last November based on Spark 2.3 with Delta Lake 0.4. It's a very old versions. And we deliver this feature, this project to our customer at this match. And our customer migration their works and migration their scripts and their circles to these features to do to performance the update and delete and sign off at this May. Also in this September, we forward port our optimization work and our features to Spark 3 and Delta Lake 0.7. Yes, I will introduce some data about this feature and usage. The data is end of September. Totally, first I will introduce the performance. totally we got 5 to 10 times faster than the open source version in our scenarios. And over 10 business units are using Delta tables now. And more than 2,000 production tables has converted to Delta tables. And we have over 3,000 update delete statements per day. And so before introduce our implementation, let me back to 2019, why we choose Delta Lake. Before this, we developed a new file format for Spark. Its implementation is very like a have ACID, but it's not good on availability. And we just provide its API, not a circle. And in that time, Databricks open source their product, Delta Lake. And the Delta Lake provided a full, bring ACID transaction to Spark. And it's provided the Scala Java API to the update, delete, and merge into. It's very easy for us to evaluate the protocol, and it's need minimal changes to comparable with Spark. So also we compared some similar projection. For example, Hoodie and Iceberg. We found that basically function they are similar. And for example, in that time they didn't support the circle, and they cannot use a very complex join, but they provide ACID and the basic API. So it's hard to say which one the performance is much better than the others. It depends on the scenarios. Finally, we choose Delta Lake. Our project has 4 stages. In the first stage, we from the last November to this March, we are finished the fundamental functions. We refactor Delta Lake to support a legacy Spark 2.3, and we finished the cross-table updating, deleting syntax. Also, we need vacuuming to resolve the small files, and we provide a circle-based time travel. In the stage 2, the main work is bug fixing and the performance. So we do many improvements to improve the performance. In the stage 3, we migration our work to Spark 3 and Delta 0.7. And we found that it still consumes many memory. So we did many things to reduce the memory. Also, our customer want to support subquery in well. In the stage 4 is now, we are investigating more challenging things like a runtime filter, the ordering. So go back to the stage 1. The challenge is in that time, the Delta Lake 0.7, 0.4, it didn't support a circle. So, and the Delta Lake required Apache Spark 2.4 and above, but our version is 2.3. And even the Spark 3 supported the update delete syntax. It only used the single table update, but we need a very complex update delete. And we have many our internal features and internal optimizations. We also need to integration these features with these features. So in this stage, our implementation is we support the circle in 0.4. And also we implementation the cross-table updating and deleting and insertion, and provide a circle-based time travel. Besides, we finished the automatic vacuuming. So the major work in stage 1 to support Spark 2.3, we add some patches in Spark 3, and we backport the update delete code with data source v1 to 2.3. Also, we downgrade the partial code gen interface in Delta Lake 0.4. Also, we rewrite the resolution code with data source v1. So what is cross-table update delete? Give you 3 cases. There are 3 different databases. They all support cross-table complex update delete. For example, in the Teradata, if we update T1 from T1 and T2, then we set T1's column to T2's column and T1's other column to some expressions. In the conditions, we set T1's column 1 equals T2's column 1 and other conditions. You can see in the right side, this is a full syntax for the join with the update. So to achieve this, we didn't use Delta Lake Java API or Scala API. We just use a Spark session extensions. We implemented this in Catalyst, so it can benefit by Catalyst. And also we injected some reservation parser rulers in the Spark session extensions, and we store necessary metadata in high meta store. I rewrite it use data source v1. Here I will give you some basically process about the update internals, but this is not a deep dive session, so I won't go to the details. You can see in the SQL-based G4 files, we change it. We add a form calls. Then the form calls will be parsered in Spark and generate a source. So they will be generated. Finally, it will be generated as a update with join table nodes. The update in the source side, it maybe contains multiple joins, and finally the update with join nodes will be transformed to update with join commands. In these parts, it's very similar like the merge into process. The difference here is we support bucket tables. And here is similar, here's the insertion internals. The insertion internals is changed a lot in Delta 0.7. But even in Delta 0.7, it only supports static partition insertion. But we have already finished the static and the dynamic partition insertion. So here also we support bucket tables, and use the bucket tables. We can distribute this in buckets. In this slide, you can see we add an insert into data source EKC nodes. Use these nodes to do the insertion. We can easily to insert with some adaptive query executions. Okay, here is just show how the insertion works. It will use here is I want to see is use the in static partitions, and also we provide the dynamic partitions. Another thing is we in the stage 1 we finished the circle-based time travel. We provide 2 ways. We can use a rollback command to rollback a table to his history. For example, we set version to 2, then it can go back its history, go to his snapshot 2. Also, we can access a table with its version with the command add. For example, we can update a table from a table with its version to access his history. Also, we can access it in the form. And we finished the auto vacuuming. Firstly, I will introduce our architecture background. In our Spark, we have 2 clusters. First, the Apollo clusters is store the data, and the Hermes cluster will perform jobs. So we have many. Our Spark is on Yarn, and our one business unit have one Yarn queue, and in one queue we have 1 or more Spark Thrift servers, and there is a one queue called resolved. This is not used by our customer, so there is a one Thrift server in the resolved queue. So in each Thrift servers use listener to store their data metadata to third-party storage asynchronously, and they listen these 6 events. The Spark Thrift server in resolved queue will double check the table metadata if the event's lost. Also, the service server in the low queue will trigger automatically vacuuming and shows UI. And in this session, our main contribution is we support cross-table updating, deleting, and we support update, delete with multiple table joins. Also, we can refer the join condition. Also, we provide insertion with static and dynamic partitions, and auto vacuuming and the SQL-based time travel function. So in stage 2, we in online, and we found that there are still some gaps in performance between the Delta Lake and the conventional product. And also we found in a very big query that Delta table is very easy cause memory, auto memory in Spark driver. Also, we need to migrate, manage the capacity and resolve the small file problems in Delta. So this stage, we did many optimization work. First is bucketing join, and the second is we resolve small file problems automatically. And we write the auto join to reduce shuffle, and we provide many filter push down to reduce the file scan and the memory consumption. Also, we provide a Delta UI to manage the vacuuming. Here is a bucketing join case. We restore the bucket specific information in Delta table metadata, and its use required child distribution. It can retire as a shuffle. For example, there is a big Delta table about 5 terabytes, join with small tables. Why this here is a join? Because in Delta, update with a table or use merge into command. Also, we are use 2 joins. First is inner join, another is outer join to do the update. So this is the internal of the commands. In this join, it will, if the 2 big table, it will provide the sort merge join. Before that, it will very easy cause auto memory. After our patch, it will finish in 3 minutes. And we also resolve the small file problem. In current communication version, in 0.7, it add a repetition if necessary method. In this method, it's use a configuration. If user set this configuration to true, Delta will add a repetition and to resolve the small files. But if user didn't set it, it will generate many small files. But it's not good for us because our user didn't use API. So, and our user didn't want to set some configurations. So our solution is before write the file out, we converted the plan, add insert into data source nodes. So in this picture, we add insert into data source nodes in the plan. Then this plan in the Spark strategy, it will transform to insert into data source exec. And in the before its execution, it will be added the repetition if it's really necessary. You can see for this ensure repetition, we will, if it is a bucket table, we no need to repetition again because it should be partitioned by bucket column. For partition table, it will be partitioned by the partition column. If we're non-partition and non-bucket table, it will distributed by round robin. So it's not every time to add a repetition work. And we want to reduce the shuffle data by we rewrite the heavy auto join. In the merge into command or our update with join command, there is the auto join. Even there are some predict in the right side, it still needs all the rows to fill the file to write to performance the join. So there are many rows in the join. We remove the right side only predict from the join conditions to its filter, and you need the join. And you need the join with the right side. At the right side, we will apply the anti-predict filters first. Then by our testing and practice, after we patch this patch, our sort merge join could be 5 to 10 times faster. It depends on how much data is skipping from the shuffle. Here is the example. In the left side, it's where the sort merge join in merge in 2, and there was more than nearly about 80 billion rows in this sort merge join. But apply our patches, it's only 5 billion rows, and then it's only all the rest 60 billion rows. So this performance is much faster. And also we provide a Delta UI in our resolved queue. In this queue, we can get many metadata informations our vacuuming. So our contribution in the stage 2 is we provide the bucket table and the bucketing join. Also, we can resolve small files automatically. And we rewrite the heavy auto join to reduce the shuffle date, and we provide many filter push down to reduce the sort table scan. You can find it in these 3 pull requests. In the stage 3, we planned to upgrade to Spark 3 in this year, and our customers need to use subqueries in the where condition to update some data tables. And also we have many features like file index, materialized view, range partitions. These features, this optimization works didn't work for data tables. So we need to do that, need to finish this. And also we are considered availability and robustness. So in the stage 3, we have already finished our migration work to migrate our changes to Spark 3 with Delta 0.7. Also, we have support subquery in where, and we did many more optimization works to reduce the memory consumption in driver. Here I'll give you the subquery, how to support subquery in where. Here is 3 delete or update circles. They are very complex subquery in his where condition. Currently now we support in exists, not in with is not none, not exists. Corollary subquery, nested subquery, multiple subquery with conjunctive. But we didn't support not in, without is not none, scalar subquery, and multiple subquery with disconjunctive. And we support subqueries by rewrite the update node plan. So here is example. We update, here is a subquery in subquery example in where. So before we rewrite, the original plan is the in subquery expression is in the join condition, and we rewrite it to use inner join. We can use the inner join to update the table. Another case is we use not exists. So the original plan is the not exist subquery expression in join condition, and we write it to use in the source side we use a left anti join to join the target table and the source table. Then we use this inner join with the updater with the target table. So in stage 2, our contribution is we migration all of changes and improvements to the latest version, and we support subqueries in where. Also, we did many reduced memory consumption works for driver. For example, we skipping schema information in merge with some big table, some tables if it read from the catalog, and then others. Here is a picture to show the performance. Before that is the commercial data warehouse. After we finish our stage 1, the performance, here I need to see is this is the duration. So it's the low, the better. So, so after stage 1, the performance is bad. And when we optimize in the stage 2, finish the stage 2, the performance is better. and the duration is done. In the stage 3 and the end of the stage 3, the performance is nearly like the conventional data warehouse. The next is our feature work. So we have many features like a range partition for Delta, and we are working on file index for Delta. Also, we have already did the runtime filter join optimization. We hope this can also benefit the Delta. Also, we are investigating CRUD and hope it could be do more faster updating. Also, we are working on zero ordering to faster the scan, and the native engine is also, we are also interested. Okay, that's my session. Thank you.